So my name is Matt. I'm the Chief Solutions Architect at Neo4j. My responsibility is making Neo4j solutions out there easier to use. And one of the key things that we've been seeing is that you know, in certain projects we had like thousands and thousands of lines of Python code being written and stuff like that. And there is a certain maintenance risk attached to that. So when I got the opportunity earlier this year to join Neo4j, we saw a nice synergy in me being the chief, well, the founder of Kettle open source data integration project, and Neo4j lacking some data integration functionality to join forces. And so that's what we did. And so today I'm going to go over a few topics. And what is Kettle? Talk a little bit about its place right now, the Neo4j plugins that we wrote, and then I'm going to go straight into a bunch of demos so you can see more real life what's going on, to keep it a little bit less PowerPointy and a little bit more practical. Please bear with me. My poor laptop has a Hortonworks virtual machine on it running, the sandbox, and so let's hope it doesn't fall apart. Anyway, so let's get straight into it. Kettle is also called Pentile Data Integration, and it's arguably one of the most widely used ETL tools on the planet. It's the tool that internally Google, Facebook, LinkedIn are standardizing on because they can pretty much do whatever they want with it, right, internally. And so it carries an open source Apache public license, meaning that you can pretty much grab it and do whatever you want with it as well. And so we have a large community marketplace, and it's easy to embed it and install it and distribute it. You can download it from SourceForge, the Pentile project, and you can look for PDI, Pentile Data Integration, CE Community Edition. All right? What's in the name? Kettle was originally the Kettle Extraction, Transformation, and Transportation and Loading Environment. It's also called PDI for short, like I said. Architecturally, it's a completely metadata-driven engine, pretty much like Informatica is. So we don't generate any sort of code or scripts or anything like that. So you define what you need to do in the GUI. I'll show you an example. And then you execute that wherever you can run your engine, from a Raspberry Pi or a Lambda, all the way to MapReduce or Spark jobs in large clusters, right? So we have two types of workloads. One are jobs, and one are transformations. Jobs are like one thing after the other. If this goes right, then do this. If something goes wrong, send off an email or do something. And transformations are parallel streaming data processing workloads, right? So we had designed it to 100% exposure of engine through UI elements. So we have a user interface. I will show you something about that later on. And everything in the architecture in the tool is pluggable, so everybody can write their own plugins in Java usually. And so we build integration points for others, so that you can run this piece of Java code or this engine anywhere you want in your own web application, or do whatever you want, right? And the goal is to allow the user to avoid programming anything. So do as much in a sort of UML-like graphical way. But at the same time, we know that that's like a pipe dream that never happens. IBM did many attempts to get that running, but so we allow the user to program anything in JavaScript, Java, SQL, regular expressions. We have plugins for Python, Ruby, R. You know, there's a lot of that going on, right? And it carries like a fail fast and fail early, kind of like mantra. PDI was like always like pessimistic data integration, assume that it fails. So we have top class logging, data lineage in there, execution lineage, and so on, right? We have a straightforward Java SDK. I will make sure that you guys get this slide deck in some form so you can click on the links. I'm sure that the organizers will distribute this, and if not, I will on my Twitter somewhere. Okay, so we have a couple of community cool tidbits. One is Spoon Git UI integration with Git, allowing you to see differences between versions and revisions of like a transformation. Web Spoon, which is a web interface to the full Spoon UI that we'll demo later on. The datasets project that I'm working on myself, which allows you to build transformation unit tests. And so there's a marketplace with dozens and dozens of plugins. And the project on GitHub has over 1,000 forks, so that's nothing to sneeze at. Let me just quickly jump into Spoon so you can see what's going on. Can everybody see this? It's maybe small at the back, but yeah, there's room at the front, right? So if you download this, you have Java 8 or later running, and you run Spoon, then you can run this on Mac or Linux on Windows, so on these 3 platforms. So we have transformations, and the idea is that we have a whole bunch of categories. I'm sure I can zoom this in for the back. And so these icons, like CSV file input reads a CSV file. You know, there's like a whole bunch of them. Getting system information, reading JSON, LDAP. There's like a whole lot of them. Microsoft Excel, property file, S3 files, SAP, SAS, Salesforce. You know, so whenever you come across any of these data sources, you don't have to program those again. You just grab Kettle and use that. So you do this by dragging your CSV file input here, double-clicking it, configuring which file you want to read. You know, we have helpers to configure the fields, the formats, whatever. And like you see, there's a lot of cool stuff in here, like support for parallel reading of files, anything to crank the performance up. So this project has been going for 17 years now, and has a lot of features for performance and parallelization. All right. So that's pretty much how that works. So you design your transformation, and these transformations are basically saved as XML files that you can check into GitHub. I still have a lot of things to cover before I run out of time. So the Neo4j plugins. So you just take Community Edition and download the plugins. We are using like a shared Neo4j connection definition, and you can use variables, and you know, you can encrypt the passwords. There's a lot of Kettle infrastructure that you simply use, right? It uses the Neo4j Bolt protocol and the Neo4j Java driver 1.6. Most of the interactions with Neo4j are done using Cypher. And you can download them on our GitHub project. We're doing very regular releases of those plugins because they're getting a lot of mileage now out in the field, and we get a lot of feedback, new feature requests from the field. So the Neo4j Cypher step is the first one. That one allows for reading and writing. Allows dynamic Cypher queries to be constructed in previous steps using a little bit of JavaScript or from some file, whatever, and then execute them. It does support batching, of course, for node creation or merges. And it also supports unwind statements and parallel execution, of course. I will show some demo later on about that. The Neo4j output step is the oldest one. It was written by Bart. And so we picked that up and improved performance a bit. It also supports like unwind statements when you have like create statements that are all identical. It's easy to use unwinds, parallel execution, and a dynamic label. So the labels can come from previous fields so that you can create relationships or do partitioning on the nodes. So it supports these. The graph output step is a new one that we're working on. And the idea there is that we create logical models of our graphs, and so that we can do, like you see in the example, a simple field to node property mapping, and we will generate the cipher for you automatically, right? All right. So the first example, you know, loading data into Neo4j, that was this first section. Load some simple nodes to get started, right? So we're going to read a CSV file in parallel and load the data into nodes in parallel. And I'll try to make sure you get those examples as well. So 0, 1, load nodes. Let me zoom this in a little bit. So we created a parameter here. It says 5 copies, but that parameter might change if you have something like in test or in production. So parallelism can change, right? So, but in this sample, we read like a 1 million line file in parallel. These are the fields. And so we're going to add labels in parallel and create nodes. So there's a 5 swim lanes, basically, of streams of data. And so the way that that works is for every copy that we define, we get like a thread going on. In this case, we have 5 different, can I zoom this a bit? 5 different threads doing each 33,000 records a second, so 150 plus nodes a second that are loaded in parallel, right? Please note that that does not always work. Make sure you don't have any indexes on that table, because otherwise you might get concurrency issues. But it's the sort of thing that we do. In this case, we simply said, okay, we have like our shared connection. We configured it with variables, so you can basically copy this information over from development to production and simply change the variable configuration file, and that's all you need to do. So we're using creates, which we use as the unwind statement, and the label can be dynamic, but in this case it's just customer. For selecting the fields, you can just say, okay, I want to have one field or all of them. In this case, just select whatever you want as properties, right? It's pretty straightforward. The step allows you to create one node, 2 nodes, or let's say 1 node or 2 nodes in a relationship. So the relationship also is dynamic in nature. So a nice building block. So when you're doing demos like this and you're loading tens of millions of records into Neo4j, then you come up with the problem, how do I get rid of all the information in my database? So to demo the cipher step, I created a remove everything from your database, kind of like a transformation. And this is actually a job. So this one sets the variables for you, because we check this into a GitHub project. So Neo4j has like an examples project, an examples GitHub space, Neo4j.examples, and we created a project called Kettle plugin examples. If you have your own plugin, your own examples, please just do a pull request, and we'll put them in there. But this is just something that but this one is in there. And for example, so we can open this one. So for example, this one gets like a list of all the database constraints. I don't think there's anything in there, but bear with me. So you have like a bunch of unique constraints. And so we need to remove these before we can start dropping nodes, right? So what we do is we build this cipher statement says drop, and then drop constraint, whatever comes behind it. And then we execute this dynamically. We just say drop constraint, and there all the constraints are gone, right? It's pretty much similar to what APOC does, right? But we want to just make a variant. Drop indexes is pretty much the same. Relationships and the nodes and the relationships, they kind of like go one step further in the sense that they first count the total number of rows and nodes in there, and then batches it up. Say I'm going to remove every 100,000 rows to make sure that Neo4j doesn't topple over with an out of memory, or doesn't run out of transaction space. But this is like the APOC variant of that, right? So you can run this, and what you will see is that Kettle will like keep track with a small sand runner of where you are. And this is a job. So the green arrows mean follow when the previous job entry was successful. And so you can click on it and it goes red, which means follow when there's an error. And the third one is obviously unconditional follow path, right? So with this, you can build like complex workflows and say, hey, something goes wrong at a very high level, catch the error, send off an email to the operator, or you know, similar to the steps, we have a whole bunch of categories for doing conditions, file management, scripting, you know, bulk loading. There's a whole lot of things. Like anyway, so you could, so for example, you could do like if something fails, or before you start running, ping a host, see if the server is up and running, see if a port is there, see if the database is connectable. You know, that's the sort of thing you would do in a defensive job, right? Does that make sense? All right. All right. So we did load node and remove all data. Now we show off the graph output step, which is something that I think has some potential for future development. In a way, it's similar to what Neo4j ETL does, with the distinct differences that you can create your own model instead of having it automatically generated from a third normal form, right? So let's take a look at that one. Nope. So this one reads a Beers file from my colleague Rick van Bruggen. He's quite proud of it, although he shouldn't be all too proud of it because it contains all sorts of bad data, right? There's like asterisks in here. There's like duplicates that you can almost see with the naked eye. Some of the data, like here, it's just like double, and it's like it's kind of messy, right? And the beer types, they're listed, comma separated in a field. So what you typically do in these kind of scenarios is you clean up the data quality parts. Sometimes it's complicated. In this case, we use a regular expression to remove some asterisks. Splitting up the beer types in multiple rows is similar. We use a comma and 0, 1 or more spaces to separate, and then we generate multiple rows for every beer type in there. We create a number field, a floating double point field for the format. And then we add like a strength evaluation so that we can, with our Cypher queries, easily get all the strong beers and the almost non-alcoholic beers, right? So this is typically something that we do in Neo4j. Instead of having to put where clauses on match statements on properties, we just create like almost like an analytical dimension, what we used to call in the in the world of Ralph Kimball. In this case, it's just another node. And for Neo4j, it's very easy to chase these nodes because it's just chasing pointers. So once we collected all the information that we want, and in other more complex scenarios, you might do lookups in Hadoop or in Mongo or whatever, right? So we map these beers onto a mini graph that we have here. And this is early days, but my colleague Eric Monk, he's working on a more fancy kind of like Cypher workbench, he calls it. So I hope we can release that next year or so. But in this case, we simply say these are the properties, descriptions, and the whole thing. In any case, so once we have the model, we can just do a mapping from the input fields to the properties, right? So we have like a, let me just delete those for a second. We can just map them, the brands, and just do that kind of thing, right? And once you have that, you can just update the graph with one step instead of different Cypher statements, create separate nodes. And the cool part about this is that it will generate Cypher statements depending on the existence of primary key values for the node. So if, for example, there's node type, that means I don't have to create a node and I don't have to create a relationship because it doesn't exist, right? So in these cases, when you have like 4 nodes, it will create 4 nodes, 3 relationships, 3 nodes, 2 relationships, or 1 node and no relationships if no other satellite nodes are available. So this step does that automatically for you. So let's take a look at maybe the browser. before people doubt. So this is the sort of thing, so the very high percentage alcohol for the people in the back. So yeah, so it kind of like solves this for you because you drew the relationships and the nodes up front, right? All right. Cool. Let's go back to the presentation. Maybe any questions so far? No? Yeah? Sorry? Yeah, so we support pretty much any relational database out there. Let's take a look. So we have, for example, you create a transformation, and this is called the table input step, but it supports basically any kind of SQL query against, yeah, all these database types. Anything from very old database, relational databases, anything with a JDBC driver or an ODBC driver we support, right? So that makes it easy to get the data from, say, any kind of Oracle or Mongo or from HDFS or Hive, or you get the picture, right? Actually, since you asked the question, I have a book for you, a giveaway. Pick it up maybe after. This is a new book, Kettle. It's a tile data integration quick start guide. It's a small, quick getting ready. It's 150 pages. So now it gets trickier. So maybe we want to do the same thing, you know, but with streaming data. In this case, Kafka. So we have a Kafka stream, and we want to update the similar graph, right? So the first thing I'm going to do is generate some data because I need to have some data coming out of the Kafka. So I'm going to write to a Kafka producer. I'm going to read the same Bear files, but all over and over again because it's too small of a file. And I'm going to limit the speed to 100 rows a second. Otherwise, yeah, it's getting messy because that virtual machine, that sandbox can get crazy in memory consumption. So let's start this up. So this thing is now putting out rows to Kafka. So we've encoded the data into a JSON message so that it flies into Kafka. And all right, so let's keep this running. And now we're going to process it on the other side. So we have a transformation, a Kafka consumer. And what we do is we allow people to define a transformation here that processes this for a batch of records. That batch can be 1 to any kind of number of records. And pretty much this is the same kind of code that we saw earlier in the CSV. So we do a graph update. And the only thing that gets added is parsing this JSON message back using some expressions. From this side, we allow you to define a Hadoop cluster, or specify the Kafka servers directly, right? So it's the Zookeeper port or something that you have to specify. You have a comma-separated value of. For each and every one of these steps that I demonstrate, there's a help button here on the bottom, and it goes straight to the documentation, so you don't have to search too hard. So what we do is we say every 1,000 records, you basically push this data into Neo4j, but if you have to wait more than 5 seconds, whatever's in the batch, push it out. So that's basically all there is to it, and you specify the transformation to use. So once you start running this, so it takes a while to initialize, but once it gets up and running, you see that every 1,000 rows, 2,000 rows, 3,000 rows, it picks it up. And before you know it, it's the speed will you know, balance out at around 100 rows a second. Now it's a little bit higher because it had some stuff to do up front, right? The queue was filled up. But that's basically how that goes, right? Pretty straightforward. So this allows you to do pretty complicated things like have a Kafka stream with updates, maybe filter out some records that you want, maybe do another lookup into, I don't know, Mongo or Memcached or whatever, right? So, and the cool thing about this is that this transformation then can be run on any kind of server that you have. We have our own server, of course. Pental has a server. There's a server delivered with it. But you can run it as a script somewhere and monitor it in your own environment. You can do whatever with it, what you want. These things are designed to run forever. To my knowledge, there's no memory leaks in them anymore. The same defaults are working to run forever. So anyway, I still have like 20 minutes. That's fine. Any questions about this so far? Go ahead. Yeah. And so feeding back things to Kafka, that's a good question. So I have a few more books. So here's one more for you. So feeding back to Kafka, so there's like various ways where you could say, oh, so I built like a trigger on the Neo4j database, but you can also say like, I know that I'm updating a certain node, so I might as well say, hey, I'm updating a node, put like a filter in there, and then say, hey, I'm putting that message back on another Kafka queue where some other process can pick it up. And then not only you know about it, but the whole organization knows that something changed in Neo4j, right? So that's a very good point. Yeah. So you can tie these together and go ahead.
Are the rules that you're applying to the previous demo applicable to Kafka as well? Are you utilizing the same rule set?
We're using standard Kafka interfaces. I'm not sure what you mean, but.
So I think in the previous demonstration you just did, you were applying some kind of rules or filters.
Yeah.
Data. Is that the same rules filters that you can utilize?
No. So we take the data from Kafka and then we apply our own filters, right? So you can do anything you want. We have hundreds of steps, conditions, anything that you can do. The rules for these steps are pretty simple. So they get a row from a previous step, they do something with it, and they pass it along to another step, right? Similar to how MapReduce gets like data from HDFS, you process it and hands it back to the ecosystem. And then it goes through the reducers and combiners, right? It's the same thing. So we have Kettle, by the way, running as MapReduce. You can just visually design it and run it. Yeah, a book for you. Another question? I have one more left. Go ahead here.
Neo4j output supports APOC libraries?
No, you have to use a cipher step. Then you can call any kind of APOC library. So the cipher step, you can call any kind of APOC, right? The Neo4j output step writes directly to nodes and relationships.
So you won't support it?
Yeah, this one's for you. Yes?
Straightforward. Does it still support, or do we have to use the full UI, or is there a Java capability where we can configure things?
So the question was, can we use this and read from Oracle and straight into Neo?
With complex transformations, we have the three tables joined together.
Yeah. So first of all, you can run any kind of SQL and do whatever you want on a database that's appropriate on a database. And you can do any kind of like memory lookups or anything in Kettle, in the transformation. What's more is, like I told you, all these things are pluggable. So the Neo4j steps are not part of the Kettle project. They're not part of Hitachi or Pentao. There's something that we wrote, right? So I invite you to look at the code. It's actually pretty simple to do. And anybody can write their own. So if you have corporate libraries, Java libraries, or web services that you want to maybe encapsulate in a nice GUI, you can do that, right? That's what the marketplace is about. It's like a whole bunch of people just putting their plugins, let's call it, up there. Kettle has about 20 plus different types of plugins for not just steps and job entries, but for cart web services, like for our web server, or for database connections, like new connectors, or for even data types. So if you want to have, I'm thinking about doing a graph data type or something like along the lines of Morpheus, where we could do graph kind of like operations in stream, right? Anyway, I still have 10 minutes left, right? You have a question?
Yeah, so there are a bunch of different ways to load data into Neo, bulk loads, all that stuff.
Sure.
Which mechanisms? Like if I needed to move 100 million records in, how would I use this? Would that be a good idea?
Yeah, you could use this. 100 million is not that much. If you can get a pace of, let's say, like 100,000 rows a second, so that's doable. Right now, we don't support the bulk loader yet, but we will. So that will come. Give us a minute. We just did the. So what you would do right now is you would dump your transformation output to a file and then load that up, right? So it didn't block us right now for obvious reasons. Another question? Go ahead.
Last year, Neo4j was promoting their own integration tool. What happens now?
So nothing happens. So if you have the need to load a quick CSV file into Neo4j, use CSV load. Why not, right? We don't detract anything from the situation right now. All we say is that if the situations become more complex than that, and they always are more complex than that, no project just loads a CSV file. That just doesn't happen. It's always data quality that you have. Issues with data quality is always data that you need to join with other sources. The companies out there are no longer standardizing on Oracle. They have every database you can imagine out there, and then some. There's cloud data sources. There's like, it's getting a wild world out there, right? And this is where Kettle comes in and can help you alleviate the pain. By not having to rewrite everything that's already been written, somebody else already did that. That make sense?
Yeah, yeah.
Good question. Another one?
Can you schedule ETL processes to run?
Yeah. So we have batch scripts that you can run in cron tab or whatever. So simple scripts that you can say, hey, run this transformation or job. But obviously, you can use your own scheduler in your company, or like I said, it's very easy to integrate. My plan is for our own, for Neo4j to have our own platform where we can have our own scheduler in there, because that's not really that hard to do, right? Some user interface capabilities and proper support. Hopefully next year we will get there, but we'll keep you up to date. We haven't done any announcements on it yet because we're still figuring out, all the things we can do with it for our customers, right? So we're primarily looking at customer feedback right now.
Is Maven a requirement to install Kettle?
Sorry?
Is Maven, I noticed in your requirements there.
No Maven needed. We do recommend all best practices, of course. So one of the projects I've been doing is creating unit testing for Kettle, so that any complex transformation or calculation, you can unit test by providing a test data and golden data, and actually, if somebody else then screws up the transformation, you can find the guilty party, right? In that sense, we also support doing things like destroying your whole database every night on a separate server on a Kubernetes or Docker container somewhere, and load your Neo4j every night, doing CI builds every night. Those are best practices. We do have like a checkbox that says create indexes, and I suggest you never use it because it's bad practice. Create a separate file for that, run it properly so that you never forget to do that on a production server, that sort of thing, right? And we do support things like Git, version control, all the best practices that you want. That's what we want. But it's up to you to determine how far you want to go with that. If it's a small project and you just want to load a CSV file, use CSV load and be done with it, right? That's not the area that we play in. All right. Uh,
A few minutes back, you said that it'll create the relationships for you on the fly, so you don't have to write cipher to do that?
That's exactly true, yeah. And so that's the example that I had here, updated graph. So, so by saying these fields on input map to these properties, that's not enough to generate the cipher. But if you know which fields are primary keys and you know the relationships between the nodes, then you can generate the whole thing. Generate every cipher state, every merge statement, including the set properties. So actually, if you let's set, for example, on row 5 and 6. Let's set a debug level. So if you execute this. So in here you will see this is debugging information. You will see that it generates like a merge statement. It starts here. So merge, the sets, the relationships, the whole thing. And you can see how it came to that conclusion by following which logic, you know. Is this perfect? I don't think so yet. We still have to do relationship properties and a bunch of other things, but we're getting there, right? With more feedback from you and from the field and from our customers, I think we can get to something pretty cool pretty quickly. And the goal here is to avoid making errors. And is this the production code? It might not be, but you will get to a result faster. Users will be able to see what's going on quicker, right? And faster results often means that the project keeps going. User sees what's going on. The use case gets supported. So that's what we want to do. All right, so this is all loading. From the extraction side, I still have 5 minutes, right? You can do interesting things as well. So in this example, we do a simple export from a cipher query into Excel. This is example 5. And so the cipher query is something like this. It's the beers again. But the beers are denormalized. So we have 2 different types. So it's kind of like duplicate data in there, right? And so what this step does is collect the beer types, concatenate them by a string and a space again, so to get back to the original result, and order by strength, description, descending. So the strong beers at the top, and then output into Neo4j. So you run this thing. It's only, and so this means that you can then see like, okay, this is the output of this file. Yeah, you see the point, right? Don't know why that column is so wide, but in any case, so this is a simple example, but other examples for this are precisely maybe updating the top 10 recommendations to an Oracle or SQL Server or MySQL database somewhere for your application to pick up. After you loaded some piece of information, update that, and after every ETL job, update some recommendations or anything that the graph is strong at so that others can play along with the results. And finally, with my last couple of minutes, some cool thing that Kettle has, and it's like a JDBC driver. We have our own JDBC driver. I will have to go through that one quickly, but I love a challenge. So, so we have like the same kind of query that we have earlier, and so instead of writing it to an Excel file, we now will expose a virtual database table. That's why we have this icon here. And let me just go straight to the testing. So we created like a Neo Beers virtual database table. You will have to put like run this on like a BA server or a server somewhere so that you can communicate with it. But then you can execute SQL from it, like order by strength descending. What happens in the background is that you have your transformation reading the cipher query and doing the collection, and we generate a second transformation that's based off of your SQL. So whenever you put like an order by, we generate a sort step because it's pure metadata for us. We just generate it in the transformation. And so what you get is a service transformation, we call it, the original one, and the generated transformation containing sort steps. And then you can see basically the execution timings for that. So that allows you to not stage the data somewhere, but just go straight to Neo4j through that SQL query and get real life data. Right. All right. Questions? A few more. We have a few minutes. Go ahead.
Can the Kettle combine the different data source into one table?
Yes, yes, of course. Yeah, yeah. So we have a lot of options for joining.
I have the Neo4j table, the Neo4j database, and then I'm using the Kettle to combine those data together.
Yes, yes.
The data together.
Yeah.
Put it into the virtual table.
So you can have like in-memory joins. So where you say, for example, I read from a text file and I update, like I enrich like a stream of data. That's possible. But we also have steps for merge joins. There's various scenarios. Obviously, you know, like for streaming data, you can't really join streaming data without doing like any kind of like sampling or time boxing, right? But in the generic case, yeah, you have a lot of options for joining and lookups. And that's the strength of this virtual table as well, because you can do lookups anywhere, right? And enrich the data, and this thing supports like a lot of cool stuff, like caching, streaming data services, query push down and query optimization, to push like where clauses in your SQL down to variables in your original transformations. This is pretty cool stuff. Anyway, let me wrap up. So with Kettle and Neo4j plugins, I think you can work faster and tackle harder problems. That's basically the sweet spot that we try to get to. And we reduce risk by showing results faster. If something doesn't work, if you hit a performance bottleneck or whatever, we want to know as soon as possible so that you can start fixing them, right? And we want to keep maintenance costs under control by allowing people to use a GUI and by allowing codes to be reused optimally, namely the ones that's already written, and the ones that you need to write to a minimal, and so maintenance cost keeps under control. I think we're out of time, right? Oh, bummer. Ask me anything outside then. Thank you very much.